So in this next section, we're going to start talking about the division of radicals. So this is where we need to kind of keep in mind this top section here where it says rationalizing denominators. So the note that it's giving us is saying square roots cannot be left in the denominator. To rationalize, aka get rid of it, you must multiply the numerator and the denominator by the square root so it comes out evenly, meaning it comes out to an integer. We're going to talk about a couple of different examples in this video. So if we look at the first example here, we have the 3 over the square root of 5. The main point that this is making is that it is not okay to leave the square root of 5 in the denominator. So what we are going to do is we are going to rationalize. So we are going to multiply the numerator and the denominator by the square root. So in this example, what that means is we are going to take both the numerator and the denominator and multiply by the square root of 5. From here, we're multiplying our numerators, multiplying our denominators. We would have 3 square root of 5 over the square root of 25. If you now look at your denominator, what this has just done is it's created a perfect square. So that's going to leave us with numerator not simplifying any further. The square root of 25 will simplify to 5. And that's it. It's completely simplified. So I'm going to leave example 14 for you to do. You can either pause the video or go back to it later, but I'm going to move to the next example. So 15 and 16, very similar, but they are a little bit different. So we have 2 square root of 5 over 10. If you look at both of our radicals, they are divisible by one another. So if we look, square root of 5 divided by the square root of 10, if we were to simplify them, just like multiplication, you can multiply radicals with other radicals, you can divide radicals with other radicals. So this would then simplify to 2 square root of 2. 5 divided by 10 would leave you with 2, so the square root of 5 over the square root of 10 would simplify to 1 over the square root of 2. From here, when you go to rationalize, you're dealing with a much smaller number in terms of what you need to multiply by. Now, if you didn't see that simplifying first, that's okay. If you multiplied by the square root of 10, you're still going to get the same answer. You'll just have to do a little bit more work here. So now if we multiply our numerators, we would have 2 square root of 2 over the square root of 4. Square root of 4 is, again, another perfect square, which would simplify to 2. Now, this is an example where we can actually go an extra step because if we look, we have an integer of 2 in our numerator over an integer of 2 in our denominator, which will simplify to 1, leaving us with just the 1 square root of 2. At this moment, again, if you would like to pause to complete example 16, I'm going to talk about the last section that's in this rationalizing denominator section. Now in 17 and 18, we have multiple terms in the numerator over the denominator. So if we look at example 17, we have 4 square root of 10 plus 3 square root of 15 over the square root of 5. Multiple terms over one common denominator. The easiest way to simplify this is to break them into their 2 separate fractions. So the way that we're going to do this is we're going to take the first term in our numerator, and we're going to write it over the square root of 5. We're going to bring down the operation that we see here, and we're going to take the second term, 3 square root of 15, and we're also going to write that over the common denominator. At this point, we're going to simplify each of these fractions separately. So 4 square root of 10 over the square root of 5, square root of 10 divided by the square root of 5 is going to leave us with 4 square root of 2, plus 3 square root of 15 divided by the square root of 5 is going to leave us with 3 square root of 3. At this point, we would look to see whether they are considered like radicals, which in this example they are not. Therefore, we would leave this as our final answer. Use this example to complete example 18.